Okay, my 8th grade YouTubers, so I know you guys are a little bit excited about this video because I know that you guys have been studying finding where two linear functions intersect by using the slope and y-intercepts. But recently we've started learning something called standard form. Now, slope y-intercept is when we have the slope and the y-intercept and we used to graph those on a coordinate system. But in standard form, we have a number times x plus a number times y is equal a constant or a number all by itself. Now, we have to transform these standard form equations into slope-intercept. Now, this could be a real pain for us, but we're going to go ahead and do it this way so I can teach you guys something called the elimination method, which is a real quick way to find where two linear functions intersect instead. But let's go ahead and find out where these two linear functions are going to intersect if we still had to use the slope-intercept form and graph it on the coordinate system. The first thing we have to do, though, is we have to change these standard form equations into slope y-intercept equations. So the way I would do this is I'm going to go ahead and use blue for this equation here, and I'm going to use green for this equation right here. What I would have to do here is I would have to add 2x and balance the equation. Now, negative 2x, if I add it to 2x, this is going to cancel that negative 2x, and then this is going to now give me a new equation in slope-intercept form. You see, the y variable will stay on the left side of the equation, but then I'm going to get 2x plus 13. I could graph this if I wanted to. Now, for this first equation that I have in blue here, I'm going to go ahead and I'm going to subtract 4x, and then I'm going to balance the equation. Well, once again, 4x take away 4x. The whole point of taking away 4x is so I can isolate the y so it can look like a slope-intercept equation. Now, this slope is going to be negative 4, and that's my slope because I know I'm multiplying it by my variable x. Now, my y-intercept is going to be a positive 1, but since I'm going to make it look like slope-intercept to what you're used to seeing, I'm going to put a plus sign in front of that 1. Before, I didn't have to put the positive sign or the plus sign in front of the 1. But if I'm going to put it behind the variable x, this is what the slope-intercept equation is going to look like. Now, at this point, what we would have to do is we'd have to graph both of these equations now. And so what we would do is we'd say, okay, I can use a table value here. And I can say, all right, let's say these are my x values and these are my y values. And I want to do it this way for you guys because I want you to appreciate this is what you normally have to do when you're graphing with the slope-intercept equation for a lot of you guys. And especially if you're going to graph it to find out where the two lines cross and intersect. Let's choose 0, and let's choose the value, let's say 2. Well, I'm going to put 0 here, and I'm going to substitute in my value of x equals 0 right here. So I take out my x value, and I put in 0. So negative 4 times 0 is 0, and 0 plus 1, when x is equal to 0, the y value is going to be equal to 1. Now I have to go ahead and substitute in my value of x equals 2. So I'm going to go ahead and I'm going to take my x value is 2, and I'm going to substitute it in where the variable x is. Well, negative 4 times 2 is negative 8, and negative 8 plus 1, that's going to give you negative 7. And you can use these two values right here in order to graph our first equation for y is equal to negative 4 times x plus 1. Well, let's go ahead and graph that. When x is equal to 0, y equals 1, I'm going to graph that right here. I always start at the origin. Since x equals 0, I stay here, and y equals 1, I move up 1. So this right here, this is where x is 0 and y equals 1 right there on top of that point. All right? Now, let me graph my other point in blue. So I'm going to go start at the origin, move out 1, 2 to the right, and now I'm going to go 7 down. So if I go and I go ahead and go 7 down, now I know that sometimes I'm going to have to actually go ahead and see that I need to add -3, -4, -5, -6, -7. And this could be a real pain, especially since our graph doesn't even go that low. I had to add all these numbers on the negative y-axis. So I'll go and I'll put 2 to the right, and I'll go 7 down right here. Now, if I connect both of these, what I'm going to do is I'm going to go ahead and remove this table so I can show you what the line will look like. I'm going to connect both of these ordered pair points right now. Okay, and I'm going to make it as straight as I possibly can without a ruler. And this is what this point would look like so far, right here. Connected to this point right here. So this is going to be 0, 1, and this is going to be 2, -7. And that came for our first equation right here. Now we have to go ahead and do the same thing for this other equation. So some of you guys are like, man, I really do want to learn this elimination method because see how much time this is taking. So let's go ahead and make ourselves a new table here. And we'll go ahead and say x and y. We'll choose, I always love choosing x is equal to 0 because it helps you really fast make this table. And of course, I'll choose x is equal to the number -3. Okay, so when x is equal to 0, I take out my x value and I substitute it in. So I'm going to take this value 2 and multiply it by 0. Well, that's 0 plus 13. Y is equal to 13. Now I'm going to put in my x value of -3. So I'm going to substitute in right here, -3, and I'm going to multiply -2 times 3 is -6, and -6 plus 13, that's going to give me a +7. Right there. So now I'm going to have to graph these 2 points, and I'm going to graph them in blue. Well, the first one is when x is equal to 0, I start right here, and now I go up to 13. So 1, 2, 3, 4, you can see it. I put 13 at the very top right here. So this is going to be when x equals 0, y equals 13. So now I'm going to graph my second point when x equals -3, y equals 7. So now I'm going to go ahead and go 1, 2, 3 to the left, because that's where x equals -3. And now I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. That's right here, y equals 7. So when x equals -3, y equals 7. And now I'm going to connect these 2 points right here, okay? And if I go ahead and just try to make it, because I want to line it up perfectly, you'll see that our 2 lines are going to intersect right here. This is where they're going to intersect. So if you take a look at where our 2 lines are going to intersect, they're going to intersect where y is equal to the number 9 and where x is equal to the number -2. This could take a lot of work, and some of you guys are like, yeah, man, if I have to do this on a quiz, it could take me forever to find out that the 2 lines are going to intersect where x is equal to -2, right here, and where y is equal to +9, right here. You can see x equals -2 and y equals +9. I don't want you guys to do that much work. So there's another method, and it's called the elimination method. You don't have to turn the standard form into the slope-intercept equation. You don't have to do any of these tables, and you definitely don't have to graph these equations on a linear function coordinate system. You can actually use another method called the elimination method. So let's see how that works here. Now, we already know where our 2 lines are going to intersect. But here's what we do instead. We take our equations, 4x plus y equals 1. You see, that was our first standard form equation. And we take our other equation, -2x plus y equals 13. See, we're trying to eliminate something. Well, let's see. There's a y here and a y here. How can we eliminate one of those y's? Hey, why don't we subtract them? Let's take them away from each other. What is y take away y? It's no more y's. You eliminated the y variable. That's what you want. Well, here's the only thing though. You have to subtract everywhere else. So what's 1 take away 13? Well, that's going to give you a negative 12 value. And now what's 4x take away 2x? Well, when you subtract a negative, it's like adding a positive. So that turns into 6x. Well, if you divide by 6 and balance your equation, x is going to be equal to negative 2. That was fast. How fast was that, guys? I mean, look at x is equal to negative 2. No graphing, no tables. We already found out that x is equal to negative 2. Some of you guys are like, yeah, but what about the y value? You can find that just as quick. Now that you know that the two lines intersect where x is equal to negative 2, you just got to go ahead and plug in the x value back into one of your equations and solve for y. So what we're going to do is we're going to choose one of the equations. It doesn't matter which one, because where these two lines cross, both of them have x equals negative 2, and both of them will have y is equal to 9. So it doesn't matter which equation we put x inside of. So I want to use this first equation because it's got positive numbers and everything's positive. So I'm going to take my 4x plus y equals 1. I'm going to use x is equal to negative 2. And I'm going to multiply 4 times negative 2. That's going to give you negative 8. Negative 8 plus y equals 1. Well, if I isolate the variable, I have to add 8 and balance the equation. Negative 8 plus positive 8 is 0, and y is equal to 1 plus 8. Well, that means y is equal to 9. And that's what we know. We know the two lines intersect where y is equal to 9. This elimination method, and just so I spell it for you guys, it's called the elimination method. It works very fast, and there's no more graphing involved. If you use the standard form equation, and if you go ahead and use the elimination method, you find out where the 2 points intersect very quickly just by eliminating one of the variables. We're going to be continuing this and going over it, and of course you have a quiz on this coming Friday, March the 23rd. I'll see you, my 8th grade YouTubers. You guys take care. See you in class tomorrow.